Hi, welcome to another lesson with Dr. Hill. Today we're talking about chemistry, basic chemistry, and we're talking about neutralization reactions. Neutralization reactions. Now, in our last lesson, what we did was we were looking at the pH scale. And the pH scale is a double-ended scale, and it's kind of interesting to try and understand why it's a double-ended scale. Because at one end you've got acid, at the other end you've got base or alkali, and in the middle you've got water, which is pH 7. Right, so 7 is in the middle, neutral, acid, pH 0 for the most acidic one, and pH 14 for the most basic base. So why have we got this double-ended scale? That's one of the big questions. And the answer is, in the thing that makes a base is the hydroxide ion. And the thing that makes an acid is hydrogen ions. Okay? But when you take hydrogen ions and put them together with hydroxide ions, they react with each other. They react with each other to form water. H and OH go together to make H2O. And what we've done is we've carried out a neutralization reaction. Now, neutralization reactions are pretty common. Everything in nature is, usually a little bit acidic or a little bit basic, and sometimes we experience neutralization reactions up close and personal. For example, if you've ever brushed your teeth in the morning before coming down to breakfast and then drink a glass of orange juice, you get a horrible taste in your mouth. And what's happening is that the base that's in the toothpaste is reacting with the acid in the orange juice, the citric acid in the orange juice, and creating a new substance in your mouth, which is called a salt. You don't taste the water that's formed. It also forms water, but you don't taste the water. But what you taste is the other thing. And that other thing is a salt. And that salt has a horrible taste. It's not ordinary table salt. It's what we call a general salt in chemistry. And you make a salt by reacting an acid with a base. So let's look at the general reaction for these two things. And this is why the pH scale, by the way, is double-ended. Because if I have something that's basic over here and I add acid to it, if I keep adding acid, I make my way all the way down to the acidic side of the scale. I just swamp out all the hydroxide ions by reacting them with hydrogen ions, and then I eventually end up with more hydrogen ions in my solution, which means I've gone from acid to base using a neutralization reaction. Base to acid using a neutralization reaction. So let's just write all that down on the board and we'll see what it looks like. So over here we have neutralization reactions, and we're going to write the general formula in words because all neutralization reactions are the same. You take an acid, okay, you add a base, and you react that, and when they react, they form water and a salt. Okay? Acid base form water and salt. Okay? Now, if you don't react the exact amounts, of course, you're going to have some excess acid or some excess base, which will leave you with a bit of leftover material. But if you've got exactly the right amount of acid and exactly the right amount of base, what you'll get is water and a salt. So let's have a look at a simple example. Let's take our acid, which will be hydrochloric acid. And we're going to react that with sodium hydroxide. And I will make water. And I'm going to make a salt. Now, where do I get the salt from? Well, the hydrogen, the hydro bit of the hydrochloric name here, for example, the hydrogen. We'll look at the formula in just a minute because it'll be clearer with the formulae. The hydrogen and the hydroxide go together to make the water. So that's nice and clear. But what have I got left with here? I've got chloric. Well, that's a chloride ion that's bonded onto the hydrogen ion in the hydrochloric acid, hydrogen chloride gas. And over here, what's left over? Well, I've got the sodium left over, and the sodium and the chloride go together to make sodium chloride, which we also know as table salt. That's the thing you sprinkle on your chips. Okay, so let's write the formulae out because that's a little bit difficult. The reason we use formulae in chemistry, chemical formulae, is because it's clearer. We get better information. We don't have to mess around with words. So this is HCl. I do a loopy L. If you don't do a loopy L, you can get confused with ones. Plus sodium hydroxide, NaOH, react to form, everybody knows water, right? H2O plus NaCl. Okay, so let's just have a look at this. We could put our states in here. This is aqueous, this is aqueous, this is aqueous, and this is going to be a liquid. Water is not dissolved in water, it's just aqueous. But we're not going to put that in just to avoid confusion on the board just for the moment, because what I want to do is look at what's happening here. What goes together to make the water? So we'll find what goes together to make the water first. I'm going to split this reaction up into two parts, right? So I have H plus OH react to form H2O. So that's balanced, two H's and one O, two H's and one O. Now, these are ions, so one is a positive, one is a negative, but it's the H that makes the acid, and it's the hydroxide, so that's a hydrogen ion, that's a hydroxide ion, it's the hydroxide ion that makes the base. Okay, so I've got my water, and this is a liquid. It's a new substance that's been formed from the reaction. Okay, now let's get the other bit of it. So I've got a Cl. Well, if my hydrogen was positive, the Cl has to be 1 negative in order to balance that substance. So it's Cl negative. And I've got my sodium, which has to be positive because the OH, the hydroxide ion, was negative. So Na plus, and they go together to form the salt NaCl. Now, it so happens that the salt, in this case, is the same as table salt, which is really where the name comes from. But all acids and bases, when you react them, will form salts, and they'll form salts of different kinds. So, for example, if I was to react sulfuric acid with sodium hydroxide, I would get sodium sulfate. All right? So there you go. There's your general formula, general reaction equation for neutralization reactions. And this shows us why the pH scale is double-ended. These two things are at either end of the scale. When you put them together, you get the neutral water. Okay? As an extra bit, what happens is you get sodium chloride salt made in the process. Okay, so I hope that was clear. In our next lesson, what we're going to do is we're going to look at some examples of these, and we're probably then going to move on to a new topic. So I'll see you in the next lesson, and any questions, pop them in the comments below.